All right, I want to touch base again on solving a linear inequality when there is no y in the equation or the inequality. We need to solve for 0. So the first thing we need to do on this one would be to subtract 4 from both sides. When we subtract 4 from both sides, we're going to get 3x plus 1 is less than 0. Well, if you remember, we can substitute in here, we can substitute in y for that 0, and we can rewrite this equation as, or this inequality as, y is greater than 3x plus 1. Now that we have it in what looks like slope-intercept form, we can go ahead and graph this. First, we want to put a point on our y-intercept, which in this case happens to be positive 1. It has a slope of 3, which means 3 over 1. So from that point, we would go up 3, 1, 2, 3, and over 1. It's also true if we make both of these negative, we still have a positive slope. So we can go down 1, 2, 3, and 1 to the left. And we could go down 1, 2, 3, and 1 to the left. Okay? If you remember, since we do not have the or equal to part, we want our boundary to be a dotted boundary. So as we go in here and get our line, we're going to make sure we get the dotted line. The dotted line means that points that lay upon the boundary are not part of our solution. Once we have this, it says that our solution y is greater than 3x plus 1. So we need to shade the side that is greater. Remember, we can always check the ordered pair 0, 0 if it's not on the line. If I plug 0, 0 into this equation, I have 0 is greater than 3 times 0 plus 1, which would be 0 is greater than 1. Is that a true statement? Yeah, of course not. So that means that this point is not part of the solution, which means we need to shade in the area on this side. So let's go ahead and do that today with a highlighter, and let's go with a green since we're using green. And we would shade everything on this side of the boundary in with green. And let's see, let's go ahead and fill it in. Let's use a color that looks right. So that's what the graph of this linear inequality would look like. That's a take.